There's a standard that concerns itself with rational or irrational numbers and what happens when you add or multiply them. So let's start with non-decimal representations. And what's the difference between rational and irrational? Okay. If it's not a decimal, then rational numbers will be your typical numbers that don't have a square root and don't have a special character like pi, for example. So maybe 5, it could be any fraction as long as, again, you don't see a square root or a pi. Anything negative is fine. Be larger numbers. Those are all rational. Rational actually is defined as the ratio of any two integers is the fancy way of putting it. Irrational numbers, the ones you work with most often in non-decimal form, are going to be square root of something. So square root of 2, square root of 17, square root of 91. You do have to be careful with this, though, because that might slip one in on you. What about the square root of 9? I'm going to write it on the rational side because the square root of 9, well, that is actually 3. Whereas if you take the square root of any of those, it's a decimal. And we'll talk about the decimals in just a minute. There are other irrational numbers. Pi is the one that you have encountered in the past. Pi, of course, is always associated with the circles, the circumference of any circle divided by its diameter, or anything that has a pi in it. Okay, they might give you a fraction and it have either a square root or a pi in there, like pi over 4, for example. That would be irrational if it has that square root or if it has that pi. The only exception would be if the square root down here is something you can actually evaluate to a whole number. All right, so that's non-decimal. With decimal, okay, if they give it to you as a decimal, the rule is rational numbers will at some point terminate or repeat. Okay, so terminate just means ends at some point. 5.2, 6.175. Okay, it doesn't go past that at all. Repeat would be something like 3.4444, and it just keeps doing that forever, dot, dot, dot. Okay, sometimes you may say a dot, 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 or they'll just write it like this, 3.4 with a little bar over it. Okay, it's shorthand for it repeating forever. And it doesn't have to be one number. You might have something like 7.126, and that might repeat forever and ever. That would be 7.126, as such. So if it terminates or repeats, that means stops or repeats, then it's rational. Irrational neither terminates nor repeats. Okay, and the only way we can really represent that would be 5.1243 dot, 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 which means, or which suggests that there's no repeating pattern that we can see, and it just continues forever. Another example, 16 point, I'm just picking random numbers here, 93447 dot, dot, dot. Okay, it just continues some random pattern. That would be irrational. Okay, so if it stops or repeats, it's rational. If it does neither, it's irrational. And again, in non-decimal form, if it has a pi or a square root, as long as you can't take that square root, then it's irrational. If it doesn't have either, it's probably rational. The standard asks, what happens when I add and multiply, say, 2 rationals, 2 irrationals, or whatever? And here are basically the rules for that. If you add a rational plus another rational, the answer is going to be rational. Okay, every time. It's what we call closure in mathematics. This is the fancy name for that. Rational times rational is rational. All right. However, if you mix it with irrational, the answer is irrational. Okay. Anytime you add a rational with an irrational, you're going to get an irrational. And when you multiply a rational times an irrational, it's going to be an irrational, as long as the rational number was not zero. Okay, there is an exception on that one. If you multiply anything times zero, it's going to be zero, which is a rational number. So you have to be careful for that. Now, usually if you add or subtract or multiply two irrationals, the result most often is irrational, but there are some exceptions to that, so we're not going to worry about that. We're only going to look at when you do rational plus rational or rational plus irrational. All right, so just looking at some examples, we'll finish up here. Is the answer, we'll just say, is it rational or irrational? Let's look at 4 examples here. Rational or irrational? That's the question. Okay, so for my first example, we're going to add 6/7 to pi. Okay? Well, ask yourself, is 6/7 rational or irrational? 6/7 has neither a square root nor a pi. It is a fraction, but that's fine. So it's rational. This is rational. Pi is irrational. Okay? So what happens when you add a rational and irrational? The answer is irrational. Okay? How about the square root of 4 times negative 3.4 repeating? All right. This one's a little tricky. The square root of 4 is actually rational because remember, the square root of 4 is the same thing as 2. You can do that one. When I say do it, when you take the square root, it's not a decimal. And negative 3.4 repeats. So since we have a repeating decimal, that is rational. Okay? Anytime you, whether it be add or multiply, anytime you combine two rationals, the answer is going to be rational. Okay? 2 more. Of course, you can pause in there anytime you need to stop and think about it for a minute. What if we do something like the square root of 26 times 5.41? Well, the square root of 26, you can't take that square root without a decimal. That's irrational. 5.41, it terminates. Okay, so it's rational. Terminates, remember, just means stops. But irrational and rational, this is not zero. That's the only thing you have to watch out for. Irrational times rational, the thing is to think, well, if there's an irrational involved, the answer is probably going to be irrational. If it's just rational, then the answer is going to be rational. But if there's an irrational involved, the answer is going to be irrational. The last one, say we have negative 1.41 ... plus 7.6 with a bar. All right, this ... implies that you're just going to continue haphazardly, okay, that you're not repeating 4.1, or else I'd put a bar over it, but it's just going to keep going. So this is irrational plus, now the bar means it repeats, so this is rational. But again, if there's an irrational and a rational, the answer is going to be irrational. The only way you're going to get a rational answer is if both the things you added or multiplied are rational. Rational and irrational numbers.